Hey everybody, Tim Brzezinski here. In this screencast, we are going to explore several ways that you can engage your geometry students in modeling the real world around them in 3D. So yes, real world, I mean, Toblerone to me is real world, right? And why do math teachers love Toblerone so much? Well, it's the only thing in life you could think of that comes in the shape of a triangular prism. And an added bonus, that base is an equilateral triangle. So the thing is, right, we learn a lot about equilateral triangles in any geometry class, right? So why do we have to stick to only 2 dimensions? Why not work in 3? Here, we're going to do just that. We're going to play around in GeoGebra 3D Graphing Calculator. We're going to explore several ways we can have our geometry students mess around, explore, build this thing, right? I always never told students how to do anything. I like to have them explore, have them figure out, have them play, all right? I would ask you to do the same if you would choose to engage your kids in such an endeavor here. But let's get started. I'm going to screen share. We are going to rock and roll. So here on my computer, I have 2 things open. I have GeoGebra's 3D Graphing Calculator right here on the left. And over here, I got the descriptions of the Toblerone right here, okay? So one edge of the triangle right there, it's 3.5 centimeters long. The prism height, or the distance between those parallel bases, right, is 21 centimeters. So how do we start here? Let's go in GeoGebra 3D and mess around. Now, students often learn. Now, this is not the first task I often ask them to do, right? But the thing is once they start playing around this app a lot, they get used to it very, very quickly, okay? So in terms of actually messing around and creating, say, an equilateral triangle, right? I like to always maximize, and my students tend to do it too, the number of times 0 is a vertex, right? I mean, 0, 0, 0. And again, I'm just trying to keep, make things go quickly here, right? I want to keep the screencast shorter. But the thing here is that if each triangle side is 3.5 long, well, perhaps we could put one other vertex on an axis, right? 3.5, comma, 0, 0, right there, if that makes sense. Okay, and so therefore, well, the third vertex is going to be somewhere up in like La La Land, some free space here, somewhere in this plane containing the blue z-axis and the red x-axis, right? But where would it be? Or maybe sometimes students like to put 0 in the middle. What if we were to put this at -1 3/4, 0, 0, and we'll move this guy down to 1 3/4, since 1 3/4 is half 3.5. See what I mean? It's a scale there. So where on the y-axis are we going to put this thing? Well, let's play. Let's actually mess around, see what kind of tools we have here. We got a bunch, actually. Now, perhaps the easiest means is to use the regular, right? I mean, equilateral triangle is a regular triangle. What does it mean to be regular, right? Well, see. So all sides congruent, all angles congruent. So let's touch on those 2 points there. And we want 3 vertices, right? And then kids are, oh, that's cool, but wait a minute, I want it to go sideways. I don't want the base to be on the gray plane. I want the base to be like, say, what if I want to turn this up 90 degrees? Now, could a kid build this so the prism goes up this way? Absolutely. That's not wrong. But I want to think outside the box a little bit here, just to explore the tools. All right? Now, to think, what would have to happen with this triangle in order for point C to be on the z-axis here? Well, it'd have to get rotated up 90 degrees, right? So we can use the rotate tool. There is one, if they find it out. And we could rotate around a line here. So let's actually click on this. It tells us what to do. Select object to rotate, then line and angle. So the object is the triangle. The line is the x-axis, right? And what's the angle? 90 degrees, isn't it? And enter. Boom. There it is. Right? I could also do the same with point C as well, since I want to get C up there, and then I could just extrude to the prism later. Don't have to. But again, that rotate tool is pretty powerful, because in 3D, you just don't rotate around a point. You really have to specify a line at which you rotate about, right? So rotate around line is highlighted, so I'll click on C. I'll click on the x-axis, and let's make it 90. Your kids can work with this. They very much can, right? And so there you go. Right? So that's one way we could do it. Now, there's several other ways. Again, this may be a little longer than I wanted to, but I wanted us to really explore the richness of the 3D graphing calculator here. So let's go back and take a look here. We have the point there. I'm actually going to hide this polygon right here, the first poly. We'll hide the second polygon, right? And I know C prime right here is that point there, but to show it here, let's go to settings. It's actually an auxiliary object, so we're going to actually show them right here. It'll make a lot of different things up here. All right. So there it is, but let me hide C prime. Now, some other students may decide to, use coordinate geometry approach and say, hey, wait. If this is 1.7500 and this one's here, some students can deduce from, either using trigonometry or actually, well, you get exact values, but also properties of special right triangles. But isn't that going to, if I cut that in half, isn't it going to be a 30, 60, 90 triangle? And therefore, 1.75 times the square root of 3, right? There's another way we can actually make that, and we can go ahead and use the polygon tool right here in order to do just that. See, A, B, D, and then close. And now I have another equilateral triangle right here. There's like a third way we can make it. How else could I do it? Let me erase what I just did. Again, we're exploring tons of ways we can make this thing, first of all. Right? Have our kids mess with it. Some teachers want to, especially after you do a unit with constructions, compass and straight edge, we could do this in 3D as well. We're used to drawing on a 2D surface, that is the gray plane, but we can do it in 3 space. We just have to specify an axis about which. I'll show you what I mean here. So let me hide T1 here. Let me go, I'm going to hide D as well. So I was doing a workshop virtually in Denver Friday, and one teacher came up with this. I've never done it this way before, but she wanted to do it. But she used some of the circle tools here. She said, I want to do a circle with axis through point, or I think she said the center and radius here. So select center point, direction, then enter radius. Well, right here, if I select the center point, right, and then the direction, I think, is this is the y-axis direction. It's axis direction, perpendicular. Click on the y-axis there. Now I enter the radius, which was, what, 3.5? All right, enter. You see how it made a circle now? I'll turn the tool off here. It made a circle right here with center A in that green axis. Notice is perpendicular to the plane containing the circle. I'm going to do the same thing with this one here, but I'm just going to use another tool here to show you how to do it. The circle with center through point. Select axis. Well, actually, we'll use the same one again. Select axis here. So we'll center it at B. Touch the green y-axis, and then we'll still make the radius, what was it, 3.5? Yeah, that's what it says there. Enter. And there it is. And now the intersect tool right here under points will allow me to actually make that third vertex right there. All right? Pretty cool. And now I can go ahead and use the polygon and make that equilateral triangle. A, B, F, and then A. And that part is done. A lot of ways. You see, the possibilities are endless here. All right. So let's go back, and I'm going to hide the circles now under circle. All right. And so let's check this out here. Now I want to make the prism. I could do a bunch of things. All right. In a few other screencasts, we talked about the translate tool, right? Translate by vector. All right. One thing I could do is I could actually create a vector whose magnitude is the length of that, is the height of that prism, 21. So, but I'm going to make it go down the y-axis here. So vector 0, 21, 0. See how I have an arrow that's going like crazy along that direction right there? So now I can go ahead and tell GeoGebra to say, hey, I want you to translate now. We're going to translate. It's under transform. Let's translate that equilateral triangle, touch it, and touch the vector. And now look at there. I can do the same thing for the point, touch the vector, the point, touch the vector. That's one way to do it, okay? And we can use the polygon to form the other faces, right? But let's go back. Another way you can do this. After all, this is a prism, and so I'll have kids try to figure out multiple ways to construct this thing. And they say, look at the tools. What do you have here? Especially the styles. Oh, there's an extrude the prism tool. What the heck does that do? Select the polygon, then enter the altitude. Well, the altitude is the height, isn't it? So if I select this, the altitude is 21. Okay. Okay, well, it put it out in this direction here. But Mr. B, I want it to go in this direction here. So let's undo. What should I do, you think? Kids deduce, well, let's try making the altitude negative. Mathematically, it doesn't seem to make sense. But if we think of a negative as the opposite direction, right? I could touch it and then type in -21, hit OK, and turn the tool off, and look at that. I have my, looks like I have a replica of my Toblerone. Pretty cool. So what do I do at this point? I'm going to save time here. What I'm going to do is I'm going to go here at File. I'm going to go to Save, and I'm just going to call it TOB for Toblerone, shared with link, right? So what this does when you save a file in GeoGebra here, it's gonna be saving. It says saved successfully. But what it's going to do is it creates a code right here. All right. And what you would want to do is close that out. All right, let me go to a new tab here. I'm going to close it out. Leave and see how TOB is right on my GeoGebra profile here. I'm going to open it up, and even though it kind of looks ugly the way it is, right? But that's what I left. If I ever wanted to go back and edit, I just go here and open an app, and I can play with it and edit it some more and save it again. But if I look at these digits here, all right, and I'm going to go to my iPad that's up and running here, any tablet, okay, device agnostic, even though I just happen to have this connected here, right? I can go ahead here and type in that. I could type, if I go here to the 3D graphing calculator, right? I could type in that RVZ blah, 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 right? If I type that code, R whatever you got, it'll come up. But I'm actually going to just save time because I have it made already. I don't feel like typing those characters in. I have one called, I did one at a Steam talk, so I just typed in Steam, and there it is. It's already, I cleaned it up already. I just saved that time. But look at that. There it is. All right. And now I press AR, and I aim it to the floor, or to the table, I should say. And there it is. Voila, let's get this baby out here. Now this is like the icing on the cake. This is exactly what we built. It's just a cleaned up version of it. Now look at that. Right there, ladies and gentlemen. Boom. It fits. Well, I think it fits pretty well. But you can have your students recording screencasts of this thing. Let's model the world mathematically. Yes, I mean, like, students need to be able to do things, but at the same time, I can't think of any other app that allows students to build mathematically, but the power here is that we can now test this model. How good is this model we built in GeoGebra? We could superimpose it right on the Toblerone right there. And there you go. With GeoGebra 3D and augmented reality, ladies and gentlemen, the world is your playground. You can model this. Let's say I might want to model my mug here. Or, you know what, hey, could I, just I don't want to take too long. Let me type in the word Steam again. What if I actually put one Toblerone right next to the other, like this, but this is at the midpoint right here. Actually, another one here. You could actually have students go back in the next day and create a composite structure here. So check this out. I'm going to go to AR. So what I'm going to do here is do this. I think I put this right at that black spot. It's the midpoint right there. Okay. And now I hit it. And then look at that. Right there. Again. See how well that comes out. And yeah. The better you actually make your model, the more it wants to just like lock on and just stay there. It's pretty cool. You can take screenshots, have your students record screencasts, but we can build a 3D world around us. We can even walk into them, right? Pretty cool. Whoa, yeah, take a turn on that hallway. All right, but you get what I'm saying. But the sky is the limit here to what you can have your geometry students modeling here. Next screencast, we're going to actually do a simple Algebra 1 exploration, talk about linear functions, okay, in this app. It's so easy to use, and it's very empowering, and it's very, I think it's also intrinsically motivating for a lot of students too, because, you know, if they get to see the results of their hard work, like literally right away, it's so much fun to play with. I mean, you know, compare something like that to just doing drill and kill, worksheet after worksheet after worksheet, blah, right? There's no math teacher that would disagree with me when I say that, you know, modeling with mathematics is vital and it's important here within all the curricula here, you know, and so therefore the activities, and they need to be meaningful, relevant, through which we engage students, right? It's a motivating factor by far. So yeah, thanks for watching. I'm Tim Brzezinski. If you like what you see, feel free to subscribe. A lot more coming in this modeling in 3D and working in augmented reality throughout the curricula in this series. A lot more coming. So stay tuned. Have a great Monday.